Hello everyone, welcome to the second session of the Alan Bradley PLC series. In this session, we are going to learn about the PLC. So basically, what is the PLC? The PLC is nothing but the programmable logic controller. And maybe in a interview also, the question will be on the PLC, and you cannot able to tell them the exact meaning of the PLC. Basically, what is the PLC? The PLC is the microcontroller based device which takes the input from field devices and update the input by execution of program. Here I'm just showing you. If you are observing this PLC signal flow, in this PLC signal flow, what you are observing? Here you can observe the input side is given here. This is the input side and this one is the output side of your PLC. This is just for your more understanding purpose. Basically what happened, it's just like a controller. Okay, so that is the reason I have said it is based on it is just like a microcontroller based device, right? It takes the input from field device. Here you can see this one is the field device. What we can see, this is, let us assume that this one is the switch and this one is the stop push button. Okay, stop push button or the start push button. The input may be anything, right? And here what you are observing on the output side, let us assume that one lamp is connected and here load or anything, just for the example, let us assume that on output side the motor is connected, right? So how it will work? So when I press the switch, accordingly the input will send to the CPU of our PLC. And what is the purpose of CPU? The CPU will update, CPU will process the input and accordingly at last it will execute it and we will get the output in terms of the lamp, in terms of the motor. So basically there are so many components which are available in the PLC. So very soon we are going to learn about the number of components. But here you can observe the input module, the processor memory and the output module, right? So basically here on the left side you can observe the number of input. Just for your example, input number 1, input number 2, input number 3, 4. Depending upon our application, we need to select the PLCs. For example, if you require the 8 inputs and the 8 outputs in order to fulfill and in order to complete your project, right? So based on this digital input output or analog input output, we need to select the PLC. Ready? And here on output side, the right side is for the output. O1, output 1, output 2, output 3, output 4, output 5, like this. Ready? Here what you are observing, here you can observe the I:0/6, O:0/7. So this is the input address of your field input device. See, field input device may be anything. That may be a limit switch, that may be a push button, maintain switch, momentary push button, right? Even sensor also. And here O:0/7, that is nothing but the output, right? See, I'm just telling you the meaning of this address. In upcoming session, I'm also going to tell you about the addressing, right? So here I'm just going to highlight it. So here you can see the I:0/6. I means what? I is nothing but the input. The 0 means what? That is nothing but word number. And the 6 means what? We can see bit. What we can see? We can see bit. Okay. In software, we can see bit, and in hardware, what we can see, the 6 means what? The 6 number terminal means to the 6 number terminal we have connected this input or this switch. Similarly, here you can see 4. Means to the fourth number terminal we have connected the stop push button, right? Similarly, here you can observe the O:0/7. O means what? The output, or we can say it file liter also. The 0 means what? Again the word number. See, word means what? One word equals to 16-bit. Always remember, 16-bit means if you are using this address O:0/7, in which you will get total 16 inputs, right? 16 inputs. But in case of the Allen Bradley, what we can see it 0 to 50. 0 to 50 means what? Total, what we can see it 16 inputs and 16 outputs. Ready? Now similarly here also the seventh number is nothing but the seventh number terminal in hardware terms, and in software terms we can say it 7 number bits. Similarly here also fifth number bits or the fifth number terminal. Here you can observe the 1 is given there and here the 0 is given there. So let us assume that if you have used all the 16 inputs and you require the one more means a few more inputs, right? So for that purpose you just need to change this. Instead of 0 we just need to write down the 1. Okay, so again 1 means what? Here the 1 is nothing but the word number and the 1 word nothing but the 16 bit. Means for this address you can able to use total 16 input. See, I'm just telling you one more thing like this. Here you can see I:0/1, or it start with 0 actually, means the 0 terminal. Accordingly 1, 2, right? And your last address that will be I:0/15. Okay, and if you require the few more inputs, then accordingly you just need to change the word number I:1.0. Okay, it's a very simple thing, right? Now let us throw some light on the components. Basically the components are very important part in the PLC. But before that, at least you should have the basic knowledge of the types of PLC, the manufacturers, right? Application advantages and disadvantages, right? Because as the project engineer, all these things are very essential. So here I have added the structure of SMPS actually, because if you are using the PLC, so at least you should have a detailed knowledge about the SMPS. Okay, but before that, here you can see the applications of the PLCs. Almost in all the sectors or for all the operations we can use the PLCs. Means in case of machine control, packaging, material handling, sequential tasks, as well as in the process control. Means you can see almost in all the applications we can use the PLC. Means just by knowing the purpose of all this application, you can imagine we can use PLC anywhere, right? We have already discussed the advantages in the last session. Okay, now disadvantage of the PLC. So basically the cost of PLC is very high, right? So that is the disadvantage of PLC, but the company can afford the PLCs. The reason is that there are so many advantages which are getting from the PLCs, right? So company can afford it. Now here coming toward the manufacturer, here you can see the Allen Bradley is the itself manufacturer for the hardware. Okay, but for the software you can see the Rockwell Solution is the manufacturer for the software. Along with that, the one more manufacturer is there for the hardware, Reliance Electric. Okay, so you just need to remember about the Allen Bradley PLC right now. Okay, basically if we are talking about the PLC, the most important part is that the PLC comes with software as well as hardware also. Software as well as hardware also. Okay, means here you can see the software manufacturer, that is nothing but the Allen Bradley itself, and the software that will be manufactured by the Rockwell solution, right? That is manufactured by the Rockwell solution. Now here you can see the types of PLC. Basically, if someone asks you about the types of PLC, what will be your answer? Your answer might be, in some cases, Allen Bradley PLC, Siemens PLC, but the basic types of the PLC here you can observe compact type PLC, and the second one is the modular type PLC. So what exactly the meaning of compact type PLC? See, the compact type PLC means what? In the compact type PLC, we cannot able to extend the number of input output, right? For example, if you have a PLC which is having 8 inputs and 8 output, right? Okay. And if we are designing the program by using the 8 inputs and the 8 output, but suddenly you will get to know you require the few more outputs. Like instead of using the 8 output, you require 8 inputs and 15 output. So in this case, we cannot able to extend the number of input and output in case of the compact type PLC. This is the demerit of compact type PLC. But as a programmer, our responsibility is to supervise the things which we require, analyze the input output device. Then and then we have to go to the final conclusion. We have to go to the final selection of the PLCs, right? In that case, the use of compact type PLC will be beneficial, right? So micrologics is the type of compact type PLC. In the industrial sector, you can observe the micrologics type PLC, right? In most of the industries, they are using the micrologics 1400 controller, right? It available with the micrologics 1100, micrologics 1200, 1300, 1500 as well, right? Means as per the requirement of our project application, we need to select the micrologics type PLC. Sometimes what happen if we are using the micrologics 1100 controller, in the 1100 controller, just for the example I'm telling you, in the 1100 controller, some instructions are not supported. Okay, for example, if the instruction like OSR, right? This is just for the example. Okay, and if this instruction is not supported to the 1100, but if you want to use this instruction for your project in order to develop your application, so in that case we have to switch to the different controller. Means this instruction may be a support to the 1300 also, 1500 also, and the 1400 also. So we have to check all these things. So as per this requirement, we have to select the proper type of controller, proper type of PLCs. Now coming to the modular type PLC, here what exactly the meaning of modular type PLC? Modular type PLC means what? For example, if you have, I'm just giving you the same example, if you have 8 inputs and 8 output, right? Okay, and accordingly you have select the PLCs, but suddenly you will get to know instead of 8 output we require 16 output, ready? But you can able to fulfill this requirement in case of the modular type PLC. Why and how? The reason is that the modular type PLCs comes with the rack. Rack means what? I'm just showing you the image so that you will get some idea. Here you can see in this image, this is nothing but the rack. Okay, this is nothing but the rack. Okay, so here you can see this PLC is having total of 4 racks, or simply not a 4 rack. We can see 4 slot, right? Here it is 4 slot. Ready? This is the single rack. Okay, in this rack, what you are observing, 4 different slots. Slot number 1, slot number 2, 3, and the 4, right? But in this Allen Bradley PLC, we cannot start the slots from 0. We have to start the number of slots from 1. We have to start the number of slots from the 0, not from the 1 actually, right? 0, 1, 2, and 3. Total what we can see, 0 to 3 means what? 4 racks are here. For example, initially we have 8 inputs and 8 output, and we need to fulfill the requirement of 16 output later. Okay, so here you can see, for example, we have added the number of inputs, 8 inputs and 8 outputs, right? Means this one is here 8 inputs and 8 outputs, right? And we need to fulfill the requirement of few more output, like 8 more output. So what we need to do, we just need to add one more card. Actually, this is your digital input card, this is the digital output card. Don't focus here. Digital input card, digital output card, and let us assume that this slot is empty, right? But if you want to fulfill the requirement of 8 more output, so what we need to do, we just need to add one more digital output card in this slot. One more digital output card in this slot means we can able to extend the number of input as well as number of output in the modular type PLC, right? For example, if instead of 8 input you require 16 input and 16 output, so what you need to do, you have to replace this card, because the input cards are available with 8 inputs, 16 inputs, 32 inputs, 64 inputs. Means our selection that will be of 16 input. Means we just have to remove this card and insert the new one. Getting? And the most important part here, you can observe this slot, the slot number 0. Actually, this slot is reserved for the CPU. Right? The CPU means what? Center processing. As we know that the computer comes with its own CPU, the same way the PLC is having its own CPU. Right? Okay, here I'm just going to show you few things. Okay, now here the one more important thing, softwares. So as we have discussed about the manufacturers, along with that the types of PLCs, here compact type and modular type PLCs. Along with that, the software part is also important. Here you can see the types of PLC: Pico, Micrologix, SLC 500, Logix Pro, Logix platform actually. But in this series, I'm just going to tell you about the Micrologix as well as SLC 500. These two PLC we are going to learn in this series. See, if you are using the Micrologix and the SLC 500, SLC means the small logic control actually. The required software is the RS Logic 500, RS Logic 500, the software that will be same. Okay, this is nothing but the programming software, right? Actually, what we can see, this is the programming software. Means in that software we have to design the ladder program. Now here you can see the communication software. In this communication software, the name of communication software is the RSLex. This communication software is common to these two PLCs, Micrologix as well as SLC 500. But here you can observe some differences in terms of the I/O capacity. The I/O capacity of the Micrologix, that is 156, but the I/O capacity of SLC 500, here you can observe, that is 4096. This in short, you can observe, if you want to select the PLC for high level applications or the big projects, our selection will be of modular type PLCs, right? And for the small scale applications, for the medium scale applications, you can go with the compact type PLC. So as a programmer, you just need to know the I/O capacity. For what purpose? For the PLC selection purpose. Now let us coming toward the most important part, that is nothing but the component of the PLCs. So here you can see the first component, that is nothing but the central processing unit. The second one is the input module, output module, power supply, bus system, and the rack. So let us start with the CPU actually, because the CPU is the most important part in the Allen-Bradley PLC. So why it is important? Because so whatever the program which we are going to design and download into the PLC, that will get downloaded into the CPU only. That is the reason the CPU is very important part, and actually it is like a processor. It will control whole the plant, right? Okay, so in the Allen Bradley PLC, in the CPU we can perform the variety of operation like counting operation, timing operation, sequential operation, arithmetic operation, logical operations. Also, logical means what? For example, if you needs to add the logic for the any XYZ project, any XYZ application. So we have to start the design of logic from the logic gates like AND gate, OR gate, NOR gate. Okay. In the upcoming session, I'm also going to tell you about the ladder program of all these logic gates. Okay. See, if you are using the CPU, so you have to take care of the few important things like if you have a one PLC, right? If you have a one PLC like this one is the one, and for example, it contain total 120 inputs and 120 outputs. But as per a requirement, what you required the few more outputs and few more inputs, okay, which we cannot able to add in this PLC, in this exist rack. So for that purpose, we required a few more PLCs, right? So this is also very important part. In the some cases, we don't even know about the this concept that we can connect the number of PLC to each other. In the Allen Bradley PLC, we can able to connect 3 PLCs to each other. So in that case, we have to think about the few more things like if you are using the 3 PLCs and if you have connected these 3 PLC to each other, the most important part is that the CPU that should be inserted in only one PLC. So to that PLC, what we can say central rack or central PLC, and to the remaining PLCs, CPU should not be there. So in upcoming session, I will tell you in detail about the connections of the PLCs as well, right? So here you can see actually this is the structure of PLC. Here you can see this one is the input module, output module. In between them, you can observe the CPU, and this one is the power supply, right? So as we have already discussed about the PLC signal flow, right? Here I'm just telling you the most important part. The PLC is working on the DC power supply. So here you can see the power supply is given there. It works on 24 volt DC power supply. Getting? So 24 means what? In some cases, we don't have a provision of DC power supply. In that case, what we need to do? Here you can see I have added the concept of SMPS, that is for the same reason. Means for example, if you have a provision of AC power supply and if you want to fulfill the requirement, means the 24 volt DC power supply requirement of your PLC, in that case simply you can go with the SMPS. SMPS means what? Switch mode power supply. It will convert the 230 volt AC power supply to the desired power supply, means the 24 volt DC power supply. And here you can observe the input module, CPU and the output. So these are the 3 important things which are available in the PLCs, right? Means the input, first one is the input, then CPU and then the output. Okay, means initially we have to provide the input by using the field input devices. Means if you are pressing this push button, accordingly signal will be provided to the CPU, and the CPU will process it, update it, execute it, and accordingly you will get the output. In terms of the motor, means the motor start rotating, the bulb gets on like this. See, if you want to know more about the SMPS, you can search it on Google so that you will get detailed knowledge about the SMPS, right? So this is the most important part if you are using the PLC and if you have to fulfill the requirement of DC power supply, right? So see, actually that's all about today's session. Rest of the component we will see in the next session.